Hello and welcome to Ascent Gate Academy. Our next chapter is linear algebra. Now this is very important chapter for both GATE and engineering services. Every year you can expect at least 2 to 3 marks questions from this chapter. So in linear algebra basically we have to learn about matrices. Now the definition of matrix is it is simply rectangular array of numbers, and a matrix is represented by some capital letter and its elements are represented by small letter. For example, you can write any matrix as Aij m into n. Now this m into n, this is called order of matrix. M is the number of rows in the matrix, m is number of rows, and n is nothing but number of columns in the matrix. So first we write number of rows, then we write number of columns, and Aij, this is element in ith row. Aij is element in ith row and jth column. So let me give you an example. Suppose if I have a matrix, say if I have a matrix like this 1 2 3 4 2 1 4 6 3 1 2 3. Suppose if I have this matrix, so you can easily see that there are 3 rows, first row, second row and third row, and there are 4 columns, first column, second column, third column and fourth column. These are the 3 rows R1, R2 and R3, and these are the 4 columns C1, C2, C3 and C4. Now here if I ask you what is this element, say A22, so this will mean element in second row and second column. So this is your second row and this is second column. Now element in second row and second column is this element 1. So this element A22, this will be 1. Similarly the element say A23, this will be A23 means element in second row and third column. So this is your second row R2 and this is third column. So element in second row and third column is this element 4. So this is very standard representation of matrix. A matrix will be represented by capital letter, its elements by small letter. Aij is the element in ith row and jth column, and m into n is the order of matrix, where m is the number of rows and n is number of columns. So for example, here this matrix has 3 rows and 4 columns. So the order of this matrix will be, this has 3 rows and 4 columns, so 3 into 4. This will be the order of matrix. Now next is classification of matrices. So basically we are going to see 10 basic type of matrices. So next heading is basic classification of matrices. Now first few type of matrices are very simple. So I will simply introduce the definition of those matrices. So the first one is row matrix, or this row matrix is also sometimes called row vector. So the definition of this row matrix is if a matrix has only 1 rows, meaning that if number of rows m is 1, then in that case the matrix is called row matrix. So for example, suppose if I have a matrix A as say 1 2 3. So this matrix has 1 rows and 3 columns. So the order of this matrix will be 1 into 3, and since it has only 1 row, so therefore it is an example of row matrix. You can think of many other examples. Suppose if I have a matrix B as say 1 2 3 4. So now this matrix has only 1 rows but 4 columns. So therefore this matrix is an example of row matrix. If the number of rows is 1, then the matrix will be row matrix, or you can also call this as row vector. The second one is column matrix. Now it is obvious from the name, if row matrix is having only 1 row, then it means column matrix will have only 1 column matrix is also called column vector. Row matrix and row vector are same thing, and column matrix or column vector, these two are identical thing. Now if number of columns is 1, number of columns we represent by n. So if number of columns is 1, then in that case the matrix is called column matrix or column vector. So for example, suppose if I have a matrix say 1 2 3. So this matrix has 3 rows but only 1 columns. Now since the number of columns is 1, therefore this is an example of column matrix or column vector. You can think of many other examples. Say if I have a matrix 1 2. So again this has only 1 column but it has 2 rows. Order of this matrix will be 2 into 1, and since number of columns is 1, therefore it is an example of column matrix. So row matrix will have only 1 row, column matrix will have only 1 column. Then the third one is rectangular matrix. Now the definition of this rectangular matrix is if number of rows and columns are different, if m is not equal to n. M is number of rows and n is number of columns. So if m and n are different, then in that case the matrix is called rectangular matrix. So for example, suppose if I have a matrix A as say first row is 1, 2, 3 and second row is 2, 3, 1. So this matrix has two rows, first row, second row, and this has three columns, first, second and third column. So the order of this matrix will be 2 into 3, and since it has different number of rows and columns, there are only 2 rows and 3 columns, so therefore it is an example of rectangular matrix. The next one is null matrix, or maybe next classification is square matrix. Rectangular matrix and a square matrix are related, so first we will discuss this square matrix. Now again, it is obvious from the name itself, in rectangular matrix number of rows and columns are different because the matrix will look like a rectangle. Now in case of a square matrix, number of rows and columns are same. If number of rows and columns are same, m is equal to n, then in that case the matrix is called a square matrix. So, and this is a very important type of matrix, because we will see that for a square matrices, different types of other matrices are also defined. So suppose if I have a matrix like, say first row 1, 2, second row 2, 1. So this matrix has 2 rows and 2 columns. Since number of rows and columns are equal, therefore it is an example of a square matrix. Or you can consider another example, say if I have a matrix 1, 2, 3, 2, 3, 1, 1, 1, 2. So now again this matrix has 3 rows and 3 columns, and since number of rows and columns are equal, therefore this is an example of a square matrix. So these are first 4 types. Total we will see 10 type of basic matrices. So first one, row matrix, number of rows is 1. Column matrix, number of column is 1. Rectangular matrix, it has different number of rows and columns. A square matrix, it has equal number of rows and columns. Now after this comes null matrix. So the fifth one is null matrix. Now the definition of this null matrix is Aij is 0 for all I comma j. Now what is the meaning of this thing? Aij is the element in ith row and jth column, and Aij is 0 for all I and j. So this means all the entries are 0. Simply if all the elements are 0, say if I have a matrix of order 2 into 2, it has 4 elements and all the 4 elements are 0. A11 is 0, A12 is 0, A21 is 0, A22 is 0. So if all the elements are 0, then in that case the matrix is called a null matrix. The next one is diagonal matrix. Now this is a very important type of matrices, diagonal matrix. So the definition of diagonal matrix is Aij is 0 for all I not equal to j. Now let me explain this thing with the help of one example. Suppose if I have a matrix of order 3 into 3. I have a matrix which has 3 rows and 3 columns. Now the first row is A11, A12, A13, second row is A21, A22, A23, and the third row is A31, A32, A33. Suppose these are the 3 rows and these are the 3 row R1, R2, R3. Now you can see that the elements which are on the diagonal, this element is A11, A22, A33. So elements which are on the diagonal, for these elements you can see that I and j are same. I is 1, j is 1, I is 2, j is 2, I is 3, j is 3. So for diagonal entries, I and j are same. Now the definition of diagonal matrix is Aij is 0 whenever I and j are different. So you can see that for all the off diagonal elements, okay, these are the 3 diagonal elements for a 3 cross 3 square matrix. Now for all the off diagonal elements, these elements, I is 1, j is 2, I is 1, j is 3. So if I and j are different, then in that case the entry has to be 0. So if this element is 0, if all the off diagonal elements are 0, then in that case the matrix is called diagonal matrix. Now one important thing here, diagonal matrix is defined only for a square matrix. The reason is the diagonal is defined only for a square matrix. So the definition of diagonal matrix is all the off diagonal elements will be 0. So this will be possible only in case of a square matrix. Now let me give you an example of diagonal matrix. Suppose if I have a matrix, say I will take an example of 3 cross 3 matrix. So suppose if I have a matrix A and on diagonal I have 2, 0, 0, 0, 3, 0, 0, 0, 4. So this is an example of 3 cross 3 diagonal matrix. You can see that all the off diagonal elements are 0 and on diagonal we have 2, 3 and 4. So this will be an example of diagonal matrix. Now see, on diagonal you can have either 0 or non-zero entry. but the important thing is that all the off diagonal element has to be 0. This is the definition of diagonal matrix. Aij is 0 whenever I and j are different. Now there is another way of writing these diagonal matrices. See, we know that in case of diagonal matrix, all the off diagonal elements will be 0. So it is sufficient only to write the diagonal entries. So I can write the same matrix in this manner. Matrix A as DIAG. This will mean that the matrix is diagonal matrix, and we can write only the diagonal entries 2, 3, 4. Because once I write that it is a diagonal matrix, this means all the off diagonal elements will be 0. So for example, suppose if I have a matrix B and it is a diagonal matrix, say -1, 2, 4. So what is the meaning of this thing? This means we have a diagonal matrix and these -1, 2, 4 are nothing but the diagonal entries. If you want to write this matrix in a proper form, then this matrix will be, first row will be -1, 0, 0, 0, 2, 0 and 0, 0, 4. So this is a very important representation of diagonal matrix. You should know how to convert a diagonal matrix in one form or another. So this was the 6th type of matrix. Now the next type is, number 6 was diagonal matrix. Now next one is a scalar matrix. So 7th type is a scalar matrix. Now this scalar matrix is similar to diagonal matrix. The definition of a scalar matrix is Aij is 0 for all I not equal to j, and it's some constant for all I equal to j. Now this is the mathematical definition of a scalar matrix. Now with the help of one example, we'll see what is the meaning of this thing. So first, Aij is 0 whenever I and j are different. So this means a scalar matrix has to be a diagonal matrix. Next thing, when I is equal to j for diagonal entries. So all the diagonal entries are same. If I is equal to j, then you will have some constant k, and if I is not equal to j, then those entries will be 0. So for example, suppose if I have a matrix, say 2, 0, 0, 0, 2, 0, 0, 0, 2. So this is an example of a scalar matrix. The reason is all the off diagonal elements are 0. The first condition is satisfied, and the second condition is when I is equal to j. I is 1, j is 1, I, j both are 2 here, I is j is 3. So for these three entries, for these three elements, you can see that I and j are same, and this is some constant. So basically a scalar matrix is nothing but a diagonal matrix in which all the diagonal elements are same. A matrix will be a scalar matrix if all the diagonal elements are same and off diagonal elements are 0. And I can also write this scalar matrix as DIAZ 2, 2 and 2 because it is a diagonal matrix. So this was number 7, a scalar matrix. Now next is identity matrix. We have 3 other type of matrices: identity matrix, and then we'll talk about triangular matrices, lower triangular and upper triangular. So number 8 is a scalar matrix. Sorry, a scalar matrix we have already covered. So number 8 is identity matrix. Now identity matrix or unit matrix, these two are same thing. Either you can write identity matrix or unit matrix. So the definition of identity matrix is Aij is 0 for all I not equal to j. So again, this means a scalar, this identity matrix has to be a diagonal matrix, because if I and j are different for off diagonal elements, then that element will be 0. And this is 1 for all I equal to j. So an identity matrix is nothing but a scalar matrix in which this constant k is 1. So if I want to write an example of identity matrix, I can write 1, 0, 0, 0, 1, 0, 0, 0, 1. So you can see that all the off diagonal elements are 0. On diagonal we have 1, 1, 1. Now since it is an identity matrix of order 3, there are 3 rows and 3 columns. So we represent this by I3. I3 will mean identity matrix of order 3. And similarly this I2 will mean a 2 cross 2 identity matrix. So this means our first row will be 1, 0 and second row will be 0, 1. So this was number 8. Now next 2 types are triangular matrices: upper triangular matrix and lower triangular matrix. So number 9 is upper triangular matrix. upper triangular matrix. These are very important classification. So the definition of upper triangular matrix is Aij is 0 for all I greater than j. Now this will be the definition of upper triangular matrix. Now let me again explain this thing with the help of one example. Suppose if I have a matrix of order 3 into 3, then this will be the first row A11, A12, A13. The second row will be A21, A22, A23, and the third row will be A31, A32, A33. So these are the three rows. Now you can see that for diagonal elements I and j are same. For off diagonal elements I and j are different. Now for upper triangular matrix the condition is that Aij will be 0 when I is more than j. So you can see that the diagonal the elements which are below the diagonal here, these three elements, you can see that for these three elements I is more than j. I is 2, j is 1, I is 3, j is 1, I is 3, j is 2. So, and if this matrix is upper triangular matrix, then these three elements has to be 0. So this means that in case of upper triangular matrix, all the elements which are below this leading diagonal, those will be 0. So if you want to write an example of upper triangular matrix, you can write first row as say 1, 2, 4. Second row will be 0, 2, 6, and the third row is 0, 0, 4. So you can see that this is your leading diagonal, or you can call this as principal diagonal, and the elements which are below this leading diagonal, these are 0. So therefore it is an example of upper triangular matrix. If all the entries below this leading diagonal are 0, then the matrix will be upper triangular matrix. So this was number 9. Now I am taking example of only 3 cross 3 matrices, but it is not necessary that upper triangular matrix is only for 3 cross 3 matrix. It can be for it may be a matrix of order 4 into 4 or 5 into 5. But the important thing is that it has to be a square matrix. Only then this diagonal will be defined. Okay. All the matrices we have seen, like a scalar matrix, diagonal matrix, upper triangular, lower triangular, identity, all these are square matrices. Whenever this concept of diagonal will come into picture, that will be defined only for square matrices. So this was number 9. Now our last important type is lower triangular matrix. So number 10 is lower triangular matrix. Now again it is obvious from the name, once you know the definition of upper triangular matrix, you can easily define lower triangular matrix. The definition of lower triangular matrix is Aij is 0 for all I less than j. This will be the definition of lower triangular matrix. In upper triangular matrix, the condition was Aij is 0 for all I more than j. In case of lower triangular matrix, the definition will be Aij is 0 for all I less than j. So this means, suppose if I have a matrix of order 3 into 3, first row A11, A12, A13, then second row A21, A22, A23, and the third row A31, A32, A33. So these are the three rows. Now you can see for diagonal elements I and j are same. The element which are above the diagonal, these three elements. For these three elements you can see that I is less than j. I is 1, j is 2, so this element has to be 0. I is 1, j is 3, this entry has to be 0. Similarly, this one has to be 0. So if all the entries which are above this leading diagonal are 0, then in that case the matrix will be lower triangular matrix. So an example of lower triangular matrix you can write is, say I have 1, 0, 0, 2, 4, 0, and then 1, 2, 5. You can have 0, 0 here also, that will not make any difference. Okay, you can have 0 below the diagonal also. The only important thing is that element which are above the diagonal, this has to be 0 in case of lower triangular matrix. So in case of upper triangular matrix, element below the leading diagonal are 0. In case of lower triangular matrix, the element which are above this leading diagonal are 0. So these are the 10 basic classification of matrices. Now after this we'll talk about algebra of matrices, where we'll see addition, subtraction of matrices, multiplication of two matrices and stuff like that. So hello. Okay, so our next topic is algebra of matrices. Now in algebra of matrices, basically we have to learn about addition and subtraction of two matrices. Then we will talk about multiplication of a matrix by a scalar, and finally we will see how to multiply two matrices. So this first topic, addition and subtraction of two matrices, this you already know, right? If I have to add or subtract two matrices, suppose if I have a matrix A, which is say 1 2 3 2 3 1, and the order of this matrix is say 2 into 3, and I have another matrix B, and the first row is say 1 1 1 and second row is say 2 2 2, and the order of this matrix is again say 2 into 3. Then first thing, you can add two matrices only when they are of same order. The first matrix is of order 2 into 3, the second is of order 2 into 3, so therefore we can add these two matrices. And if I have to add these two matrices, then we simply add the corresponding elements, meaning that I will add A11 with B11. So if I add these two, I will get 1 plus 1 2. Similarly, I will add this element A12 with the element B12, so I will get 2 plus 1 3, 3 plus 1 4, 2 plus 2 4, 3 plus 2 5, 2 plus 1 3. So this will be the sum of these two matrices A and B. Similarly, if you have to subtract these two matrices, then again you have to subtract the corresponding element. So this was very simple concept. This you already know from class 8-9. So if I have to add or subtract two matrices, then you can do this only when the two matrices are of same order, and the addition will be simply we have to add the corresponding element. Now next thing is multiplication of a matrix by a scalar. Multiplication of a matrix by a scalar. Now if I have to multiply a matrix by some scalar quantity, then what we do, that we multiply each element by that scalar, meaning that if suppose if I have a matrix A and the first row is say A1 B1 C1, second row is A2 B2 C2, and the third row is say A3 B3 C3. Suppose this is our matrix A and we have to find K into A. So if I have to multiply this matrix by K, then we are going to multiply each element by this scalar quantity K. So our first row will become KA1, KB1, KC1. This will be our first row. The second row will be KA2, KB2, KC2, and the third row will be KA3, KB3, and KC3. So if I have to multiply a matrix by some scalar quantity, then we multiply each of those elements by that scalar. Now one of the very important property that we get from here is that determinant of K into A. If A is a matrix and K is some number, then determinant of K into A, this will be K to the power n into determinant of A. Determinant is defined only for a square matrix. Now determinant of K into A, this will be K to the power n into determinant of A, where n is order of matrix. Where n is order of matrix. Now this is very important concept. See here, if I have to calculate the determinant of K into A, then what will happen? We have to calculate the determinant of this matrix. Now in case of determinant, we can know that we can take any element common from either row or column. So you can take a K common from this first column, so you will get one K here, another K, another K. So in this particular example, if you want to write determinant of K into A, then this will be K cube into determinant of A. Now why K cube? Because this matrix was of order 3 into 3. It has 3 rows and 3 columns, but in general if I have a matrix of order n, then in that case determinant of K into A, this will be K to the power n into determinant of A. So this is very important property. Now next thing that we have to learn is multiplication of two matrices. So we'll learn the concept of multiplication of two matrices here. So number 3 is multiplication of two matrices. So our next concept is multiplication of two matrices. Now suppose if I have a matrix A whose order is say m into n, m is number of rows and n is number of columns, and I have another matrix B whose order is say n into p. So I have first matrix of order m into n, second matrix of order n into p. Now you can multiply these two matrices only when number of columns in A is same as number of rows in B. You can multiply these two matrices A and B if number of columns in A is equal to number of rows in B. So this is first important point. In case of matrix multiplication, the multiplication is possible only when number of columns in A is equal to number of rows in B. And say the product of these two matrices is some matrix C. Then in that case, the order of this matrix C will be M into P. This will be the order of matrix. A is of order M into N, B is of order N into P. So the product of these two matrices will be of order M into P. Let me give you an example. Suppose if I have a matrix whose order is say 2 into 3, and I have another matrix whose order is say 3 into 4. Now this multiplication is possible because number of columns in A is same as number of rows in B. And if I multiply these two matrices, then the product of these two matrices will be of order 2 into 4. A is of order 2 into 3, B is of order 3 into 4. So the product will be of order 2 into 4. Now this is first point. And the second point is that if I have to find any element of this matrix, our matrix A is Aij, order is M into N. Matrix B is Bij, order is N into P. And matrix C, which is product of A and B, is Cij, and order of this matrix C will be M into P. So these are the three matrices. Now if you want to find any element of this matrix Cij, so this Cij will be given by the formula. You have to take the ith row of first matrix. Okay, if I have to multiply these two matrices A and B, then you have to take ith row of first matrix and jth column of second matrix, and then you have to multiply the corresponding elements and you have to add that. So if I want to write ith row of first matrix, so this will be, row number is fixed, so AI1, AI2, AI3 in this way, and the order of this matrix is M into N, so this will means total number of columns will be N. So here I will get AIN. So this will be the ith row of matrix A. Now jth column of matrix B will be, column number is fixed at J, so this will be B1J, B2J, B3J, and in this way we'll have Bnj, because in matrix B there are n rows, so you will get nj here. Now this element Cij, this will be nothing but multiply this row with this column, so I will get AI1 into B1J plus AI2 into B2J, and in this way we'll get AIN into Bnj. Now let me explain this concept with the help of one example. This will be the formula to find the element Cij. Now suppose if I have to multiply the two matrices, say one matrix is, suppose I have a matrix 1, 2, 3, 2, 3, 1. So this matrix has 2 rows and 3 columns. So another matrix B must have 3 columns. So if I, so suppose our second matrix is say 2, 2, 4, and then here I have say 1, 2, 6. So the order of this matrix is 3 into 2. Suppose these are the two matrices A and B. The first matrix is A, the second matrix is B. Order of matrix A is 2 into 3, order of matrix B is 3 into 2. Now you can multiply these two matrices because number of columns in B is same as number of rows in A. Now suppose the product of these two matrices is some matrix C. Now what will be the order of this matrix? The order of this matrix C will be simply 2 into 2. If I multiply these two matrices, then order will be 2 into 2. Now say these are the elements C11, C12, C21, C22. These are the 4 elements of matrix C. So in order to find any element, suppose if I have to calculate this element C11. So this element C11 is in first row and first column. So you have to take the first row of matrix 1 and first column of matrix 2, and then you have to multiply these elements. So I will get 1 into 2 plus 2 into 2 plus 3 into 4. So this will be the value of element C11. Similarly, if I have to find the element say C21, this element C21, so this element is in second row, first column. So now you have to take the second row of matrix 1. So this is the second row of matrix 1 and first column of matrix 2. You have to take the row of first matrix, column of second matrix, and then you have to multiply and add. So this element C21, this will be, I have to multiply this, I have to take the second row of first matrix, first column of second matrix. So I will get 2 into 2 plus, next element will be 3 into 2 plus 1 into 4. So this will be the element in second row and first column of this matrix C, which is product of these two matrices A and B. Now, so this is the formula to find any element Cij of matrix C. Now there are two very important formula which we have to learn related with this matrix multiplication. In GATE also, questions have been asked on this formula on a number of occasions. First time directly the formula was asked, second time one question was asked based on that formula. Okay, now two very important results related with matrix multiplication that you have to remember is, the first one is number of multiplications required to find C. So questions based on this formula has been asked on GATE on number of occasions, at least 2-3 times. So the question is that the first formula that we have to find is number of multiplications required to find this matrix C. Now I have one matrix A of ordered m into n, another matrix B of ordered n into p. If I multiply these two matrices, then I will get a matrix of ordered m into p. So this information is known to us. Now see, in order to find one element Cij, how many multiplications are required? This is the formula to find Cij. We have to multiply the ith row of first matrix with jth column of second matrix. So this formula will give you one element of matrix C, the element in ith row and jth column. So you can see that we have I1 into 1j. So you have one multiplication sign here. Then again you have I2, 2j. So another multiplication sign here. So in this way you have total n terms, 1, 2, up to n. So number of multiplication signs will be n. So to find one element we have to multiply n times. And how many elements are there in this matrix C? So the order of matrix C is m into p. So this means there are m rows, p number of columns. So number of elements will be m into p, right? To find, for example, here if I have a 2 cross 3 matrix, so you can see that the total there are 2 into 3, 6 elements. So similarly, if the order of matrix is m into p, so this means there are m into p number of elements. And to find one element, we have to multiply n times. So total number of multiplications required to find this matrix C, this will be m into n into p. So this is very important formula. For example, suppose if I have a matrix A of order 3 into 4, another matrix B of order say 4 into 5, and I have to find how many multiplications are required to find the product of these two matrices. So this will be simply 3 into 4 into 5. These many multiplications are required to find the product of these two matrices. So this is first formula. The second one is number of additions required to find C. First one, number of multiplications. Second one is number of additions required to find C. Now here again we are going to apply the same approach. First we'll see how many addition signs are there to find one element, and then total number of element will be m into p. Now see, if I have to add 2 elements, so this means there is one addition sign. If I have to add 3 elements, then it means there are 2 addition signs. So similarly here, if you have to add n elements, then number of addition signs will be n minus 1. Okay, so to find one element you have to add n minus 1 times, and total number of element is m into p. So this means number of additions required will be n minus 1 into m into p. So number of multiplications n into m into p, number of additions n minus 1 m into p. So for example, if I have a matrix A of order 3 into 4, B of order 4 into 5. Now if I want to find how many addition signs are there, if I want to find the product of these two, the number of additions will be simply 3 into 4 minus 1 into 5. Okay, we can rewrite this formula as m into n minus 1 into p. You should remember the formula in this manner, m n minus 1 p. So here also n is 4, so 4 minus 1 into p. And you can also write this formula as say m into n into p. So these two are very important results. Number of multiplications m into n into p, number of additions m into n minus 1 into p. So on one occasion directly this formula was asked in GATE, and in 2012 one question was asked based on this concept. So after this we'll see how to solve that problem.